In this section, we will look into the signal strength measured in RSSI, and we'll also look into a demo. The AT command to get the signal strength is At+CSQ. It returns the values in the range of 0 to 30. The written values map to what is called as Received Signal Strength Indicator, RSSI. RSSI is measured in dBm, so it's a measure of received power. As an example, CSQ return value of 0 maps to minus 111 dBm, which indicates it's a really low signal strength. However, a CSQ return value of 30 maps to an RSSI value of minus 53 dBm, which indicates it's a good received power. Value of 99 indicates that the signal strength is not known or it's not detectable. Now let's look at some details on RSSI. As I mentioned, RSSI is measured in dBm. So dBm stands for so it's decibels, just a power measure of power relative to 1 milliwatt. So in the radio networks, it is used to represent the transmit receive power. So 0 dBm, that corresponds to 1 milliwatt. So 3 dBm, so every 3 dBm you have an extra milliwatt of power. So 3 dBm corresponds to 2 milliwatts. So there's a math in there to convert from power to dBm or dBm to power. If you're interested, you can look into that. So from a practical standpoint, in a radio network, so you have a cell tower, and depending on your location, the proximity to the cell tower, your signal strength is going to vary. So in this case, the case where the device is closer to the cell tower, so 55 dBm, which indicates it's a good signal strength. If you are somewhat closer, so you're going to be little less power, receive signal power, but this is still good signal power, receive signal power. But if you're farther, so your receive signal power dBm is going to be very low. It's likely that this is the conditions where you drop calls or your data transfer is going to be very low. So what factors impact the signal strength? And obviously, closer to the cell tower, the stronger the signal strength is going to be. The antenna systems on the device, so that determines the signal strength that the device can realize. And any noise or interference on the signal, especially if you're in the case where if you're in an elevator or if you're within a metal enclosure, that is going to impact your signal strength. This is my setup. I have a SIMCOM 900 module on a development board. It's got an antenna connector. Now let's look at how we can use the AT command tester to measure the signal strength of the modems. So I have a SIM 900 module on a development board. So I connect to the modem. So I find the ports and I connect. Okay, the connection is good. Clear that. So on the diagnostic window, we have a button for signal strength. So you press that. So now you can see that the At+CSQ command returns a value of 23,0. So the value of 23 corresponds to a signal strength level of -67 dBm. So this is a good range, so it indicates that the device has a good signal strength condition. You can also use the command mode. So At+CSQ equal to question mark. So that tells you the range, the values that you can expect from the modem. And then when I press At+CSQ, At+CSQ question mark is error, so that is not supported. But At+CSQ, again, just we saw before, it returns a signal strength value of 23, CSQ value of 23. Now I'm going to remove the antenna connector from my modem, and then I'm going to measure the signal strength again to see what impact it has. So we removed the antenna connector on the device. Now let's measure the signal strength again. Now you can see that it's returning a value of 0, which corresponds to -113 dBm. So this indicates that there is no signal level at all. So once we remove the antenna connector on the modem, as expected, the signal strength value is going to drop, and in this case, it's not able to detect any signal. So in the no signal conditions, you're not able to make any phone calls or make any data calls, because the modem is not connected to the base station at all.